So we're here checking out DraftShift Design. This is the Stealthchanger. So tell me a little bit about it. What do we got? How's this work?
Well, are you familiar with how Boron Tap works?
Yes.
Awesome. Well, I'm going to explain it anyways because people out there might not know.
Yeah, exactly.
So, unfortunately, I pillaged a bunch of parts off this. It got expensive building 6.
Yes.
So,
yeah, it does get expensive.
So normally we got a hot end with a nozzle coming past the vents here, and then we'd have our tap PCB here with a break beam optical sensor in here.
Yep.
So we've got a little flag on this. So that flag would go in and break the beam on the tap sensor. So since it's a flying gantry design, we can come down, the nozzle will hit the bed, and the gantry can come down a little bit and pull that flag out of the break beam for our Z offsets.
Yep.
So, but then we can go up, put it in the dock, and come down a little bit further and fully disengage and pick up the next tool. So normally, Boron Tap is a linear rail, and it's rigidly attached. We went to pins into push pins, and then magnets to lock it into place.
That's crazy. Just,
and then we've got 2 adjuster screws down here. If your print's not perfect, you need to dial out some wiggle on it.
Yeah.
It's the adjuster screws against the magnets.
Okay.
To dial it in.
So, and it's pretty solid. So I felt this yesterday, and it doesn't wiggle around or anything.
Yeah, no, it's not dialed in.
I mean,
but that's also the 1.0. We just released the 1.1 earlier this week.
Yeah.
And it is the input shaper graphs on that are more rigid than.
Yeah. So the input shaper looks pretty good on them.
One sharp peak.
Nice. Okay.
So here's a little torture test I did. So this is at least 5 changes per layer.
Okay.
And this is the extent of the waist.
Yeah.
And this.
Yeah.
So.
Yeah, that's so much.
I'm trying to push the limits and. Print it faster with less waste, but I may have gone past the limits.
Yeah. Well, yeah, we got to try to push the limits here. So yeah, this is it in action here.
So once you've got working 2.4, you get tab going on it, and then you get CAN bus or LDOs and Nighthawk speed tool boards on it, and then it's about $10 in parts.
Wow, that's crazy.
Plus the cost of your tool head.
Yeah.
So mine are about $150 each, but someone else did some bargain shopping on AliExpress and was able to source their tool heads for about $70 ish. So,
yeah, I mean, at home I've got 12, and I've got, I think 10 of them are 2.4s, and I think maybe 5 of them have tap on them. So I need to build one at least, you know, to be able to do the multicolor like this.
You do lose a little bit of wide travel with the stock frame. This portion is stock LDO kit.
Yeah.
So I added the top hat. I added the tool changing system into it.
Yeah.
So, so you lose about 80 or 90 millimeters.
Yeah.
Depending on what extruder and stuff you're using with it. So.
Okay.
But yeah, it's
great design, man. I like it.
I'm only a very, very small contributor in this project.
Okay.
CAD work has been replaced. All I did was a small part for the doc, and they've since done it a different way, a better way. I did some proofreading for the documentation. Well, there's other people who do far more contributions to the project.
Okay. All right. Well, I thank you. I appreciate your time.